Hello everybody, myself Saurabh Maheshwari and I welcome you all to the ongoing lecture series on C programming. In the previous video, we saw the concept of pointers, how the arithmetic is performed, how to access various variables through pointers. Now in this video, we will see how to make some programs based on pointers and how they actually perform during the programming. Now, first of all, we will see how to declare some pointers related to integers there, which will be pointing and storing the addresses of the integer variables. And we will also see the arithmetic related to pointers and various syntaxes that will be used for the pointer arithmetics. So, in this program that you can see on the screen is that these two variables are used, so I will make these two variables over here in the memory. So suppose this is variable A and this is variable B. These two variables might be having at different memory locations. Suppose this is at the 1000 location and this is at the 2000 location. We have selected two random memory allocations for these A and B. Okay. As per initialization, the value of A is 5 and value of B is 8. So this is the memory map of these two variables. Okay, now we have three pointer variables, right? We have pointer number, pointer with name P, pointer with name Q, and pointer with name R. So this is P, this is Q, and this is R. And all of these will be stored in some random memory location, because pointers are also variables, so they will be stored at a location, and these are the random memory allocated to these pointer variables. Okay, now we know that the content of the pointer, the content that will be coming here is would be an address, and this address would be of integer type, right? So because it is an integer pointer, so it may hold address of an integer variable. So the syntax that will be used for assigning address of A, so this is address of A, this is address of A, and if I want to assign it to this pointer P, so this is the syntax that will be followed, that is P equals to ampersand A. So as soon as this statement executes, the address of A, which is 1000, comes to P. Okay, and as soon as it stores at this place, now P starts pointing to this variable A. Okay, now you can access value of variable A without accessing variable A with the help of pointer P. Okay, now in the next statement you can see that the Q has been assigned to the address of B. So address of B is 2000, and this 2000 will be placed as a value of Q, and as soon as this value of Q is pointed, Q is placed, the value of Q is placed as a address of B, so Q starts pointing to variable B. Okay, and we can say that it starts pointing to the location of variable B. Okay, and at the value at that particular location can be accessed directly through the pointers. Okay, now so this is another type of assignment that we saw in the previous video. Now third type of assignment that we can see here is R equals to P. R is a integer pointer and it is copying the content of another integer pointer. Okay, now R will have the value of P. So the value of P is 1000. So when you want to copy by this statement, you copy the value of P, that is address of A, to value of R. Okay, and as soon as, since R is a pointer, it has stored a memory location, and this memory location is stored here. So it, this pointer will also now point to the same memory location. So this is the concept of multiple pointers pointing to a same location. Fine. So which are P and R. P and R are both pointing to the same memory location 1000 with the address 1000. and it is the address of the variable A. So any value changed at that particular address will be accessible by these pointers, or the values can be directly changed with the help of these pointers. Both of the statement applies. Okay. Now we will see how we are printing different values. Okay. Now we have used the same printf statement 5 times, and we perform four different operations. Okay. Now after these three assignments, let us now first see what are the values of pointer q, pointer p, pointer r. So can you understand this particular thing? Pointer p, it means value at address in P. Okay, so this can be expanded as value at address in P, and address in P would be translated as address in P is 1000. You can see here address in P is 1000. Okay, now address in P is this. Now value at, so this is resolved as value at 1000. Okay, now address 1000 is this. Now what is the value over here? It is 5. So this P would print 5. This first P would print this 5. Okay. Now these two hyphens are printed. Second percent %d. This percent %d takes value from pointer Q. Pointer Q is simply value at address in Q. Okay. So address in Q is 1000. Pointer Q means at value at 2000. Okay, because the address in Q is 2000. You can see over here, because it is pointing to this particular address. Now at this particular writing asterisk before pointer variable, it means it is asking for the value at address. Okay, and this value of at address is 8. Okay, so this 8 will be printed over here. Now we are using pointer r. We want to print pointer r. Pointer r is value at address in r. So address in r is 1000, and the value there is 5. So it would print 5. Okay, so this is how this output of the first line is obtained. Okay, now this is the simple variables and assigning the values of the variables, and then we saw how to print the values at these addresses. Okay, now we are looking for the pointer arithmetic. Okay, now see here this statement pointer P. Now pointer P, and this is minus minus. Now you can see this particular statement. This is the A statement. Then this is the output for A, output after A, after B, after C, and after D. And this is your A statement. This is your B statement, C statement, and D statement. So we will try to solve all these statements. Okay. A statement. A statement says pointer P minus minus. Okay, since there are parentheses there, so we have to resolve this first. Okay, now pointer P means value at address in P. Okay, value at address in P, and we can see here address in P is 1000 and value at that place is 5. So this bracket will be resolved as 5 and 5 minus minus. Now if you do 5 minus minus, so this value, okay, this value which is 5 over here will get decremented, and it will become 4. Okay, now if you try to print this, okay, so this will be 5 minus minus, and the resultant value is 4, and 4 will be at the place at the address 1000, because you are accessing with the help of pointer variable. You are accessing the value at the pointer. So value at the location was 5, and you have to decrement by this particular syntax. You have to decrement the value at address in P. So this would be read like that, and this 5 will be decremented as 4. Now if you want to print this PQR, so this pointer P is at it would print at 1000 location. So that has been now changed to 4. Now pointer q has not changed because it is pointing to b. So the value of b has not been changed and it is pointing to 1000. So this will also get printed as 4. Okay, so this is how 484 is the output after execution of statement A. Okay, now we will do the statement number B. Statement number B is an assignment statement which states as pointer R equals to minus minus pointer Q. Okay, minus minus pointer Q. So to understand this statement, we have to first see which is whose priority is more. Okay, so since the priority of asterisk operator, that is pointer operator, is more than the pre-decrement operator. So pointer q is simply means value at address in q. Okay, so address in q. So we can convert it like this. This statement means like this. So this would be minus minus and value at address in q is 8 because q has address 2000 and at 2000 the value is 8. So value at address in Q is 8. So minus minus 8 would lead to 7 and 7 would be assigned at the location at a location which is stored in R. So at R the location stored is 1000. So first we have to reduce it. Okay, first we have to reduce it as 7 because of this minus minus operator, because the value at address in Q to be reduced by 1. So address in Q is 2000 and the value was 8 and when it is reduced it will become 7. Okay, now this 7 is also to be transferred to pointer R. Okay, so the value at address in R, which is right now 4, it would be replaced by the value 7 on the right side. Okay, so both of these locations now have become 7. So if you want to print the printf after this, all the three locations, all the three pointers which are pointing to these two locations will print the same value because both the locations now have the same value. Okay, right, next is to run the uh, point number C. Okay, statement number C, that is pointer R equals to pointer Q minus minus. Okay, now understanding this would be a different thing. Okay, now we saw that in the pre-increment operator we don't required in the pre-increment operator we don't require the parenthesis specifically. Okay, why? Because when the post increment operator is there, so the priority of post increment operator is higher than the pointer variable. Okay, so if you want to first decrement the value, like solving this would be pointer q is the value at address in q, which is 7, and 7 would be applied over at the value of r, which would make no change because it is already 7, and this itself will get reduced to by 1. Okay, it will get reduced by 1. So that would be minus minus. Okay, so that would give you minus minus. So this 7, okay, value at address in q is 2000, so this value will become 6. Okay, so this uh, 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 the the pointer variable will be applied first, and the second is the assignment operator, and third is the post decrement operator. Okay, so one is value at address in q, which is 7. 7 is transferred to the value at address in r, which is already 7 here, you can see. And third is to apply decrement operator on the value at address in q, which was 7, and it would decremented as 6. Okay, so this is how it will be resolved. Okay, now we can see the statement change is pointer r equals to pointer q minus minus. Okay, pointer r equals to pointer q minus minus. Okay, now here we have to see that what does this pointer q belongs to. Okay, now pointer q belongs to a different memory location. Okay, now different memory location. So if we write statement number D, this was statement number C, and this was statement number B. So if we resolve the statement number D, which is pointer R equals to pointer Q minus minus, so first the priority would be to resolve this pointer Q. Okay, so the pointer Q would be the value is 6 because value at address in address in Q is 6. Okay, because Q has address 2000 and value at 2000 is 6. Okay, so the value at address in R, that is at this particular place, the value would become 6. Okay, and so this 6 value would be supplied to there. Okay, and after resolving this particular pointer statement, this q minus minus operation will be resolved. So can you find the difference between these two statements? Here the decrement operator was applied on pointer q, that is the decrement of value take place because the value was 7 and the 7 was decremented to make it 6. Okay, here the decrement is inside the q. Okay, now q has 2000. Okay, and 2000 will be decremented as the previous value of the integer variable. Okay, so previous value of integer variable, that would be if integer take 2 bytes, so the value would be 1998. Okay, and if it takes 4 bytes, so the value would be 1996. Okay, depending upon your compiler. So 1998 or 1996. Okay, so this 2000 gets decremented and this now becomes 1998. Suppose we take it like that. So this pointer who was pointing to this particular location, it starts pointing to the location number 1998. Okay, it might not be assigned to some variable, so this value may have the value of this particular location would be a garbage. Okay, so when you want to print this pointer p, pointer q and pointer r, so the pointer p and pointer r will print this particular 6. Okay, and this pointer q will print this garbage value, and for running this particular program, this is our garbage value. So to ensure that it is doing like that, you can also run a statement here, pointer q equals to 88. Suppose you run this statement before that, so the decremented of value of q is 1998, and what it will do, it will simply change this garbage value to 88. And if you print this, so this would get printed as 88. After that, after assignment of this of value to this location, the value will be printed as 88. So we have to see the clear difference between this statement and this statement number C and statement number D, that how they differs. Here in this statement C, it is the decrement operator would be applied over the value at address in Q. Okay, so that is the value get decremented from 7 to 6, and here since the parentheses are not there, okay, parentheses are not there, so this decrement operator would only be applied on this q. Okay, so on this q, if it is applied, so the value of q is 2000, so it is decremented to the previous contiguous memory location. Okay, it decrements to the previous contiguous memory location, and so suppose this is the memory location, so the q now start pointing to this particular location and it is changed from B. So this is how pointer arithmetics on integer is done. Okay, and these are the various ways that you can use to access pointers, access the integer values with the help of pointers. Okay, we will see the use of pointers on characters in next video. Thank you.